Well, I'm wondering if I've been wrong all these years when I assumed that every wood joint is stronger when it's glued than just natural wood. Let's have a look. Here's a glue up of some 3/4 inch wood, and I know that the glue joint will the wood will fail before the glue joint does. I know that in a glue up like this. But what I don't know, I've always assumed that whenever you glue wood together, that it's always stronger, and I don't really know that. So today I'm going to be testing some other joints. I'll show you those in a moment. But the one that I'm most interested in, here's a glue joint here, and my question is that glue joint stronger than the natural wood, or is it about the same? So we're going to find that out in a little bit. Now, before I start with the testing of my other joinery, I just want to remind you I've got a little public service announcement for later on. But what I want to start off with today is a few weeks ago, I did a video on 2x4s and why we don't use them for furniture. And a lot of people wondered just how strong they were. So today I'm going to go through and we're going to see just what a softwood is like for joinery. And I'm going to start off with some pocket holes. All right, here's our first test, and I've got the piston just above the joint here, above the board. So let's watch that meter. Oh, you can see it's already twisting, but still holding. Yeah, went to 200, and it was failing even before that because it was even twisting in the joint. And I used really long screws in that as well. Now, the next test I'm going to be using is the lap joint, and it's just a simple lap joint, but I've kind of modified it, and here's why. When you have a lap joint that's in the middle of wood like this, it can't move because the wood is stopping it on either side, but even on the back side, there is wood here that will prevent it. So you can get a little bit of a false test if you do that. So I've modified mine, and what I've done, I've got a lap, it's still a lap joint, but now I've cut away this part here so that that's not going to interfere with it, and also there's a gap in here. So really I'm just testing this sort of area in here. So let's put that in and give that a test and see what that does. So this test is almost ready to go. Pistons just above the wood. But in the 2x4 video, I said that I believe this would be the strongest joint. And that's because you've got a glue joint, you've got all this glue joint, and you've got flat wood against flat wood. So I thought this would be the strongest joint. So let's see if it is. I had to kind of stop because I forgot to put this little stopper in here. So let's go ahead now. That will work. Well, it did a little better than the pocket holes, but not a lot more. I'm surprised actually that didn't do better than that. But we'll take this apart and we'll see what failed, whether it was the glue joint or the wood. So I've had to put it back in the press because I couldn't tell where my glue looked good, but what I'm looking at, and it's hard to see here, is what's cracking is the wood. I'm just going to keep on pushing it down here so you can see. Because I already took this out once. Take my little stopper out there. But there you can see what's happening here. Now it's actually pulled apart the glue in there. Well, there's a good look at it. So it pulled apart. I can see wood fibers all through here. So the glue didn't fail, but the wood did. And remember, this was a very soft wood. This is spruce, so no real surprises there. But I would have thought it would have gone a little bit better, but that's what it is. Let's move along to the dowel joint. Now in the 2x4 video, I assumed that the lap joint and the dowel joint would be equal, but I'm a bit surprised, really. I thought that lap joint would do better, so let's have a look and see what the dowel joint does. Yeah, just a little over 200. And I'll bet you, I'm going to keep pumping on this, but I'll bet you that the dowels are pulling the wood fibers out either from here or from inside there. So I'm just going to keep pumping it till I get that out of there. So there's a bit of a close-up. And you'll be able to see in the article on Woodwork Web, I'll do close-ups. In fact, I'll probably pull this apart because you can see that the dowel is just pulling. The dowel hasn't failed. It's the wood fibers that's just broken, pulled the whole thing apart in there. Now I've added one more element to the mix here, and it's not one that I've talked about. And what I'm doing here, this is just a glue joint. It's just a butt joint, so it's end grain against long grain. And what I've done is I put glue on the end grain. I let it sit for about half an hour. It dried and soaked in. Then I re-glued the long grain and the end grain again. And I put a light clamp on it. You can see the glue has squeezed out. And I have no idea what this is going to do, but let's have a look at it and see what happens. Okay. Oh boy, that didn't do anything. What failed? Oh, the glue failed. Well, maybe not. Yeah. Well, the glue didn't fail. It actually brought some wood with it, but I guess it just soaked in too much. But that was about the worst. That was easily the worst joint right there. So gluing end grain into long grain. And usually this actually works fairly well, but in this case, you can see that it was a disastrous joint. Well, now we come to the testing that I was really interested in seeing. And I've taken this is fir. Now it's still softwood. Remember we were talking about SPF, spruce, pine, fir. And fir is the strongest of those three softwoods. And I have some dry, I've dug up some old 2x4s that I had here and they were quite dry. And this is fir. So this will be quite a bit stronger than that spruce. But we're not testing woods today, we're testing joints. And so what I've got a couple of pieces of wood here. In fact, I did some extras just in case something goes wrong here. So you can see there's a glue joint there. And I'm going to test this one. I'm going to put some pressure down and see how strong this joint is. Then I've got another one like this. And in this case, I'm going to put the glue joint down. So I'll be putting pressure on that and see if that's any stronger. And then I've got just some natural wood and we'll compare these three together. And with that, we'll be able to tell which joints are stronger or if they're all the same. I don't know. So let's test and see. Okay, I wrote horizontal on here so that we can see that that's where that glue line is going to be. So let's have a look at that. Ooh, it's strong. Yeah, no, it went to, I can't read, I think that's 500. Yeah, it's cracking. Okay, there's the second test, and you can see I've written vertical on this one. That's because the glue line is running down the middle of that wood. So let's have a look at that one. Yeah, right about the same. You can see that right around 500 it looks like. All right, here's the last test in that series, and this is just a piece of natural wood that's not glued anywhere. So we're going to see where it comes in at. Interesting, there it finally snapped. and it's still around the 600. They're all virtually within a few degrees of one another. Well, sometimes it's amazing what you learn. You know, to be honest, I really thought that this wood, the horizontal one, would be stronger than the natural wood, but it turns out that it's actually almost the same. In fact, the vertical one was even the same as well. So I do know that like I showed in the beginning of this video, that when you're gluing up panels like that, that the glue is strong, but it looks like when you get more wood in there, the glue is having less effect on anything. I could redo this with thinner wood and see how that turns out, but I think for my purposes, it's pretty much satisfied me to know that gluing wood is this way. I really thought it would be stronger, but it turns out it doesn't really make that much difference. So now we come to my public service announcement, and I do that because I don't make any money on these. It's just something I think is an interesting little product, and let you know what it is. So Kevin makes these. Kevin lives in Illinois, and he makes these little, what he calls a drill shield. And what it is, you put it on your drill press. I'm going to show you how it works in a moment here. You can clamp it down, and it's got some windows so you can see what's going on. But what it does, you can plug your standard 2-inch vacuum hose into here, or your dust collector, which is what I'm going to do. And when you're using a Forstner bit on your drill bit, or on your drill press, you know how much you get these great big flakes coming off. And this little item, it's remarkable. It actually sucks up all of those pieces, all of that dust. I modified mine a little bit by adding a little bit of thickness on here, so I can actually clamp mine to my fence here. So if I'm making multiple holes, I can just keep moving the board along underneath it, drill a hole, move the board, and drill it. And he might actually be changing his modification on that. But I'm going to show you how this works, and I'll put some links in the description box below and in the article on Woodwork Web. If you're interested in looking at it, I encourage you to at least go and have a look at it. Kevin is making these one at a time with his little digital printer, so it's not a big factory thing. So let me show you how it works. It's really cool. Okay, so I've just taken a moment to set it all up here, and I've just clamped it down just for a demo because I want you to see just what a great job this does of getting rid of all of these Forstner bit chips. So I'll turn the dust collector on. And there it is. I was pretty impressed. Look at that. There's not a bit of dust anywhere, and I've got a nice clean hole. So that's a great little item, Kevin. Well, I like it when I learn something, and today I learned something, and that is that when you're comparing glue in wood, it really doesn't make any difference, especially if you have thicker woods. The glue apparently doesn't make any difference. And of course, other woods would be stronger than the fir that I used, but that wasn't the point. We were testing vertical and horizontal and natural wood. And guess what? They all came out roughly about the same. So anyway, that concludes my video for today. Lots of cool tests that I've done in the past, and I'll put one of them up here or up over here, and you can have a look at it. I'm Colin Gannett for Woodwork Web. Thanks for watching.